Okay, let's look at the situation that we've described in this problem. A ball is chosen at random and the color is noted then returned to the bag, and this process is repeated 3 times. So first off, let's recognize that we have 5 green out of 10, so probability of drawing a green is a half. And we've got 3 blue out of 10, so probability of drawing a blue is 3 out of 10, 0.3, and probability of drawing a red is 0.2, 2 out of 10. Okay, so from each, when we now are repeating the process of drawing them out 3 times, then we've got an intersection of events. And so when we're defining our random variable here, we are realizing that these are all our outcomes, 27 outcomes that we have, and the number of green balls drawn, such as this outcome here, green and then a green and then a green, the number of green balls drawn is 3, then we've got 3 lots, 3 multiples of the probability of drawing a green, which is 0.5. So let's look at the probabilities of some of these outcomes. So the first one is what we looked at. There it is, probability when x is 3. That's probability of a green, and then a green, and then a green. So that is a half times a half times a half, all to the power of 3. Same thing. Okay. So let's keep going. So when we look at probability that x is 2, then from all the list of 27 outcomes, which ones are where green occurs twice? Well, it could be green, green, blue, or green, blue, green, or blue, green, green. Or instead of a blue, it could be red. And so that are these outcomes here that I've shaded. Now, let's find the probability of this event. So first one, this is here now where we have a green and a red, where you've got 2 out of 10. So how many times does that occur? Where you've got a green, green, and a red. We've got 3 of them. And then we have this situation where we've got green, a green, and a blue. And we've got 3 of those. So altogether, we've got, by multiplying that out, we've got a total probability of 3/8. Alright, what about when we get only 1 green ball? Well, that is these events. So from this list, what is the outcomes where green appears once? And if we look through the list, we'll count that there are 8 situations, and that's these 8. Okay, so it's these ones that we've shaded here. Well, actually there's more, there's 12 altogether. Well, there you go. So let's write down the probabilities. Here we go. So there's 6 lots of that type. And what about if red occurred twice and green occurred once? Well, there's 3 of them. What about if green occurs once and we've got 2 lots of blue? Well, there's 3 of them. And there we have our total probability by multiplying them out. And we simplify the fraction and we get a 3/8 again. Okay, last scenario when there's 0 green balls. Okay, so that's the 1, 2, 3, 4, 5, 6, there's the 8 outcomes that are left. That's that set there. Okay, so well, we could have here 2 reds and 1 blue. Well, that occurs 3 times. Well, what else could we have? We could have 2 blues and 1 red. That occurs 3 times. And then we could have just 3 blues, blue, blue, blue. That's one outcome. And then we could have another outcome, which is 3 reds, red, red, red. And that's that outcome. So we multiply it all out, simplify the probability, and we get 1/8. So let's summarize all our probabilities in our probability table. There it is, 1/8, 3/8, 3/8, 1/8. And we could see that, well, all those probabilities, they sum to 1. So it follows the correct property of a probability density function. Fantastic. So from that, I wonder what the scenario would be like now if a ball is chosen at random from the bag and the color is noted, and then the ball is not returned to the bag. And this process is repeated 3 times. So every time we draw out a ball, we just put it down and we note the color. And when we are not returning the ball, well, we've got conditional probabilities because the number of balls in the bag decrease by 1 each time. So that will be the next type of exercise to examine the probabilities, and I wonder what will be the difference in the probability table.